Hello everybody, my name is Tom Wardle and today I'll be making a presentation around energy storage solutions. Before I'd like to continue however, I'd like to discuss UN Sustainable Development Goals which are important to this presentation. UN Sustainable Development Goals are a series of goals and targets set by the UN to help improve global development in a sustainable and environmentally friendly way. The goal chosen to be the focus of this presentation is Goal 7, to ensure access to affordable, reliable, sustainable and modern energy for all. The way we store energy and electricity on a large scale has a tremendous impact on the environment, helping to make previously non-viable sustainable energy sources scalable. New ways of generating energy can help provide less developed areas of the world the resources necessary to improving their standard of living. What is stored energy? Stored energy or potential energy is when any form of energy ranging from thermal to mechanical energy is trapped or accumulated within a system or object such as a battery. This energy can be released or transferred into a different form of energy through a form of interaction with the object the energy has been stored within. An example of potential energy is the diagram on the right showing a bicycle going up and then down a hill. Going up a hill, energy is exerted to provide the energy necessary to propel the bicycle upwards to the top of the hill. The energy exerted is then stored within the bicycle and is then let out when the bicycle goes down the hill. The importance of energy storage in modern engineering. Energy storage solutions are an incredibly important part of the modern engineering world, most recently regarding applications in renewable energy. Many renewable energy sources, such as wind and solar, do not have the ability to produce electrical power at a constant fixed rate in differing operating conditions, which makes wind and solar alone unsuitable for power grid supply, which requires a stable supply source. Examples of large capacity battery storage solutions, such as the Tesla Mega Battery Farm located in Jamestown, Australia, aim to solve this problem by storing excess energy generated by sustainable sources to be used later when demand exceeds supply. Benefits and drawbacks of energy storage. Benefits: can deliver backup energy in emergencies and during outages, can reduce the use of fossil fuels and decrease greenhouse gas emissions, and can enable the integration of intermittent renewable energy sources into the grid. Disadvantages: cost. One of the main drawbacks is the cost of energy storage solutions. Maintenance. Energy storage systems require regular inspection, including checking the battery level and ensuring the system is properly working. This can be a problem for property holders and businesses who might not have the time or ability to perform maintenance tasks. Batteries such as lithium-ion batteries, if not properly looked after, can become potentially dangerous. Most notably the incident at Luton Airport where an electric car burst into flames, causing large-scale damage to the parking area. Lifespan. Energy storage systems have a restricted life expectancy, commonly going from 5 to 15 years, depending upon the technology utilised. At the point when the batteries arrive at the end of their life, they should be replaced, which can be time-consuming and costly. Sources of renewable energy. Renewable energy sources are significant in accomplishing sustainable development, which aims to guarantee modern and sustainable energy for all. These sources are able to renew and help reduce emissions, helping make them a cleaner and more sustainable option in contrast to more traditional power generating methods. This includes solar energy, wind energy, and hydroelectric energy. Elastic aeroplane. Demonstration of energy storage and conversion. To demonstrate the importance of energy storage and to show differing levels of potential energy can decrease or increase the amount of useful energy produced, an experiment was devised using a rubber band aeroplane. A different number of rotations, 60 rotations and 120 rotations, would be applied to the aircraft over 2 tests, and the distance travelled by each would be recorded. An increase in distance with increased stored energy would help illustrate how increased energy storage can improve the performance of the plane. Apparatus: a toy aeroplane with a rubber band, a tape measure, a marker and sticky tape to mark the starting point of the test, a stepladder to ensure a consistent starting height for both tests, and for control variables, A height of 2 meters was chosen for both launches. The starting location was the same, and also the same elastic plane was used for both tests. How the rubber band shows the storing of energy. The rubber band, when wound up and released, shows how the energy can go from potential to kinetic energy. As the band is wound up, it is creating potential energy, and once it is released, it will be converted into kinetic energy. The toy plane powered by the rubber band shows the importance of storing energy and releasing it where needed, as if the energy was not able to be stored and released at the correct time, the plane would not be able to fly as it did. I will now show footage of both tests, starting with test 1.
Yes. Woo!
I will now show footage of test 2. Moving on. Results. The results of the first test showed a distance travelled with 60 rotations of 4.73 meters from a 2 meter starting height. From the second test, the aircraft was able to travel a total of 6.3 meters with 120 rotations applied to the elastic band. Upon reflection, however, there were issues regarding the flight direction of the rubber power plane, which could likely be rectified by utilising different aircraft designs, which may provide a more linear flight pattern. This would make measurements and results gathered from the test more accurate and would provide a more reliable and conclusive demonstration of stored energy. Despite this, however, the difference in distance by both aircraft should illustrate how an increase in potential energy was able to propel the aircraft much further. Conclusion. According to a forecast, the demand of energy storage capacity will exceed to a terawatt by 2030. The demand of energy storage systems is increasing worldwide. Energy storage systems are more crucial for the development of renewable and clean energy and can help to reduce greenhouse gases and emissions. Understanding this activity and topic will help everyone to become successful engineers in the future, as understanding SDG 7 will develop understanding in the need and application of storing and providing energy. Before finishing, I would like to discuss the future direction of SDG 7 to ensure access to affordable, clean, modern and reliable energy for all by 2030, and by 2030 to substantially increase the proportion of affordable and renewable energy in the worldwide energy grid, and to double the rate of improvement in energy efficiency globally by 2030. Finally, to expand the infrastructure and improve technology to deliver the modern and sustainable energy for developed and developing countries by 2030. Thank you for listening to this presentation.